Welcome everyone. Today there is something that I thought was really cool and I wanted to show you, and that is reflective loading in PowerShell. The idea is we want to be able to compile a library, a dynamic library file, a DLL basically, and we want to be able to load that into PowerShell and use reflection to grab the assembly and grab the different components or the different methods within that dynamic library and eventually execute it. Now, previously we used something like the PowerShell add type commandlet, which looked like something like this. Ignore that code for a second, which looked like something like this. Add type, and you'd give it uh, the type that you want to load, and it would compile it and give you the assembly so you can call it and invoke it within PowerShell. Now what we're going to do is a little bit different because we'll be compiling the code beforehand in C# into a dynamic library, and then we'll be taking that already compiled dynamic library file, loading it into PowerShell and doing some reflection shenanigans to eventually and finally invoke it. So I have this file here. I will build it. Okay, let's build that. This is a typical PowerShell shellcode runner, C# shellcode runner. We have our DLL import statements, our binvoke extern functions to map Win32 APIs to C#, and we have our shellcode here generated using MSVenom, and it's most importantly, notice that it is placed in this function, public static void runner. Now, runner, this name is arbitrary. It's not something that we need, but this is the name that we're going to use. And make sure that it is public and static, because that's how we're going to extract it later on. Because we don't want to, we just want to be able to extract it from the class itself without having to instantiate or do any magic through reflection. Reflection is not that simple after all. And then this is a typical usage where we allocate enough space for the actually we don't, but we just do use virtual alloc to create enough space. This is the size here, just enough space, and we make sure that it is executable memory, and set up a bunch of other permissions as well. And then we use marshal.copy from the interop services to copy the buffer, our shellcode, into the address returned by virtual allocate, and we copy as much as the size of the buffer. And then we use create thread, the Win32 API create thread, to create an executable thread out of the of that memory location. As you can see, we passed the address here, and these are a bunch of other arguments. I'm not sure, or I don't really remember what they do, but essentially we create an execution thread out of that shellcode that is in memory. And then finally we have to use this system call wait for single object to make sure that our parent process waits for us. Now in our case, the parent process is going to be PowerShell, waits for the completion of this execution thread before it terminates. Otherwise, our thread is going to prematurely terminate. Now, once we build this, we can easily go into let's remove this. Why do I have this? Okay, thank you, Visual Studio. Let's close that. Now we can go to here. I have this open already, but I have this loaded into a Samba share. Samba share that is running on my Kali VM, and in there I'm building and running my Visual Studio projects. And in here we have class library, and we can go to bin, we can go to release, and we can find the dynamic library file that we have created. Now I copied that into my Kali, so if we go back to Kali and we look in here, I can find my class library 1.dll, and we can check its type. It is a class library DLL. It's a BE32 executable, whatever, DLL. Now, oh, and is it 803386 or is it 64-bit? I'm not sure. I think that's just what it says. But it is definitely, yeah, BE32, I believe, is 64-bit if I'm not mistaken, because there's BE, which is something else. Okay, enough yabbing. Now for this one, I'm going to serve it. Let's do this. Okay, we're serving that. And if I go to my Windows box again, I want to show you how we can load that, just to simulate the whole interaction. I'm going to show you how we can load that from our victim in memory. Okay, actually this is not completely memory because we do download the file. Maybe next we'll complete the entire process in memory. So simply we instantiate a system.net.web client instance, and we use its download file method, to download the DLL from this URL to that path to our desktop essentially. And then we use the load file static method of the system.reflection.assembly class to load that file as an assembly. So now this assembly is in memory now in PowerShell. And then next we use some more reflection to extract, so the assembly.getType method to, now this is an assembly instance, and we use the getType method to grab this type from within. Notice that this is the namespace class library 1, this one, and the class name, which is class 1 from here. And then once we have the class grabbed, we use its get method instance or method to grab the runner method, and we put it in here. Now finally, once we have a reference to a method or a function, we can use .invoke 0 null, and boom, that's how we run it. Now let's go back to my Kali machine and make sure that we have this running. We have a shell here listening. Let me actually show you the options, and we have exit function, make sure it's thread, and we have lhost, lbort, and the payload set up correctly. So let's clear that, actually clear, run, and boom. Now let's go back to our Windows box and let's run that. So okay, what happened here during download? Exception calling download file with 2 arguments. Okay, something happened with the DLL, but that doesn't matter because if we go back here we go. We have a shell connected back to us. So we can do shell, I can do who am I can do echo, and that's pretty much it. Now I think this failed because the file already existed and it didn't want to overwrite it. That's my guess. But although actually that's not true. Now if we exit this, I want to show you something. If we exit this, then this shall remain intact. So just killed that thread and moved on to the success check listener, and that's it. But this is happening totally because here in options, in our options, we set the exit func to thread, which means when you exit, just send a signal to kill the executing thread. This is part of the staged payload that Meterpreter sends us back. So it exits using just a thread. If this was process, then the whole Windows PowerShell ISE process, a parent process, the host process is going to exit, which happened before. So that's why. Now I'm not sure why is this. Can we maybe do something like this just to make sure that I want to test this part first. Let's put that here. Okay, let's run that. Exception calling. I'm not sure.